Okay, let's continue. Okay, let's continue. And here what we have now. So we can put here the these values, yes, obtain it. So there was two. Just a moment. Can you write here? Okay, let's do. Okay, and now we can write here. So let's continue to here. It was 2 arcsine. I think it's clear now because just put here the result. Yes, minus sine, the value is the bounds of the integral to arc sine x over 2 again. So we need to put here 0 and square root of 2, yeah, instead of this one. So if you put square root of 2, you get here what we have here, arc sine square root of 2 over 2. What is it? What is it?
Pi over 4.
Pi over 4, yes, 2 times pi over 4 minus sine pi over 4. What is sine pi over 4 now? No, here it's not pi over 4, here pi over 2, because here you get again pi over 4 from this one. You need to multiply by 2, this pi over 4, you get here pi over 2, and sine pi over 2 is 1, yes? Do you understand me? Is it clear? When you put zeros, here we get 0 and 0. So the answer here is pi over 2 minus 1. Do we have this kind of result?
Yes, yes.
So this is correct answer. Any other questions? Any other questions? Who has questions? See you, what's your name? Okay, questions, students, please. Or again, return to the version sample, I mean. If no questions. Third question of exam sample. Okay. This one you mean? What was it? Okay, so here let's return to the third question and let's check each of them here again. So multiply by sine and f of x. When x tends to 1, sine x times f of x. Let's write it here. Limit as x tends to 1, sine x times f of x. You need to find here, is it continuous or discontinuous for the first way? Then we need to check next other ones also. So what will be here, continuous or discontinuous as x tends to 1? Continuous or discontinuous? F of x, where it tends as x tends to 1? 0, yeah? Because of x, when x equals to 1, it gets 0 here. So now your sine x, when x tends to 1, it gets to sine 1. So sine 1, it's just value, which is not equal to 0. So it will be 0 times sine 1. So the answer here is 0. Now, next B1 now. Gx minus cosine x. Where it tends now? Gx minus cosine x. As x tends to 1. G of x is given. And we have the value when x tends to 1. It is sine 1 again. Yes? But here we need to consider this part also. Because we are subtracting from gx this one. Cosine x here. Just a moment. So what is the next question here? Integral. So to be continuous again, it should be exist the limit. Yes, as x tends to x0, it should be f of x0. Or we can say by other way, here left side limit should be equals to right side limit as x tends to x0. So when left side limit equals to right side limit, we say that they are finite and they are equal. We say that it is continuous. It's continuous. Yes. When left side limit and right side limit exist, but they are different from each other. So we say that it's continuous of the first kind. If at least one of the one-sided limit does not exist or equals to infinity, In this case, we say it is discontinuity of the second kind. And also we have removable discontinuity, which means that the limit exists, but function is not satisfied in this point. It means that it's not included to the domain. So in this case, we call it removable discontinuity. Okay, so you will check each cases here and try to find the correct answer in this case, in this example. So I will left here for you. You can just take a photo or do screen and you can solve it and send me to the group. We have the discussion group also, you know, in the Telegram channel. So you can send it by this group. Then we will consider the solutions also here. Or I will send it by the group also, the solution here. Now, let's move to the next, number 4. Find the following integral here from 0 till 4. How can we solve it now?
By parts.
Huh?
By parts?
Why by parts? I think we can do it without by parts because just multiplication of x and x. Any other idea? So can we here factor out quadratic form? Can we do it? And why? If yes? Yes, of course, because of the absolute value, correct? So here we have from 0 till 4, we need to find here correct intervals of positivity and negativity. That's why here we need to consider factoring this quadratic polynomial. So here it will be what kind of x minus 2 and minus 3, yes? X plus 2, plus 2 and plus 3, x minus 2 and x minus 3. It's factoring, yeah? So, and what should we do here now? From 0 till 2, from 3 till 4, it is positive. From 2 till 3, it is negative. Yeah. And now we are doing some kind of inequality, like quadratic inequality, yes? So here we need to write these intervals, 0, 2, and 3. Yeah. 0, 2, and 3 divide to the intervals. And here also we have 4 here, yeah, because of here we have the bound of the integral. And then when we do it, so here we have plus, minus, plus, and minus, yeah. So, and, but we need, what we need? Is it correct? So here we have plus. We will open this absolute value when it is from 0 till 2, you can put any values here also. For example, 3, you can, from example, if you put 1.5, and what you get here instead of x, 1.5 if you put. So you get here positive value, yes? So that's why here, just open these brackets. When it is from 0 till 2, like divide 3 integrals from 0 till 2. So with plus x times x squared minus 5x plus 6 dx. Then put here minus integral to 3. Yeah, so this kind of integral now. X, again, I will put here plus because of, I just put here minus between two integrals. Minus 5x plus 6 dx. And then plus the last one from 3 till 4 and the same one. Okay, like this. And you can open these brackets and find your correct answer. So it's very easy now. Is it clear how to solve it? Any questions here? Okay, let's move to the next one. May I clear this? Okay, so now let's clear. Just a moment. Okay, so next, number 5, which one of the following is a primitive of the function? So what should we do here? Any idea? Yeah, correct. So we need to use here the composition of the fraction to elementary fractions. So, and here we need to write, this is x minus 2 and x minus 3 again, and divide use here a and b, correct. Aselhan is correct. So here should be this integration by division to elementary fractions. Yeah. So, but or also we can use here just find from the versions here. So A, B, C, D, we can just take the derivatives, and if it gives us the f of x, it will be primitive. That's all. Correct. Okay, now find principal part. Number 6. We have considered it very in our lectures, also how to find here principal part. Do you remember? Aselhan, Yoldashwa, you remember? Others? What was the finding principal part? Let me one more time recall it. Yeah, here limit as x tends to c. Here c is -1 in this case. F of x divided by phi alpha of x should be equals to any finite limit, and the principal part here will be L times phi alpha of x. Yeah, so this is principal part of the function. So in this case, phi is a test function, and the test function in our case is g of x. It is x plus 1. So you need to consider here this limit, and see this g here is our phi. So you can just write g instead of phi in this case. It will be same with our example now. So, and here to find principal part of this function, find the limit as x tends to -1 f of x divided by g of x to the power of alpha any equal, it should be equals to finite limit. It's very easy. Can you continue at Hamid? Guys? Yeah, okay, good. Number 7, consider the following improper integral. We'll just finish with this sample, and the next time we will continue with new sample or with your questions. Maybe please find some questions for the next advising hours, and the next advising hours will be tomorrow. Not at the same time, it will be 13:20, I think. Yeah, it will be 13:20. Okay, now consider the improper integral here. So how to find here improper integral? It is converse or diverse, we need to define here. What should we use here? What kind of theorems or what kind of instruments here we need to use? Replacement, what should we replace here? Yeah, we can do it. We can do it. For example, plus infinity. So we can just replace by t, and then from 4 find the limit. Of course, to solve the improper integral, we'll move to the limit. It will be equals to limit as t tends to plus infinity from 4 till t, and other ones here, x squared plus, so something else, x squared plus 1 dx divided by something. So I will not write here. So of course we have to solve it by this way, but in this case we can define, is it converse or diverse? If it is converse, we get here finite limit. I mean, if it has finite limit, it will be converse. If it does not have the finite limit, it will be diverges. Yes, so by the definition, that's why here first of all try to define, is it converse or diverges? We have other ways, we have comparison theorems, we have other theorems to define diverges or converge. So here, can we use here a comparison theorem? And how to use here a comparison theorem? Do you remember? Who knows? Indashva, what will be comparison theorem here? x minus a power of alpha. Yeah, 1 over x minus a power of alpha. Yes, we need to provide it to this kind of expression. Yes. If alpha less than 1, it is diverges. If alpha less than or equals to 1. If alpha greater than 1, it is converges. Less than or equal, it diverges. Okay. So yeah. Now this is called harmonic integral. Yes. Now here we can do it to the harmonic integral. First of all, if by the comparison theorem, if the biggest one converges, the small one also converges. If least one diverges, the biggest one also diverges. This is comparison theorem. So now we need to compare, estimate our given function with another function, which will be greater or which will be less. Yes? Okay, so what it tends, for example, logarithm x, for example, can we replace with another function, for example, logarithm x, as x tends to plus infinity here, from 4 to plus infinity? And okay, we will do it. And here, the last one also we have, the last one, I think it is, yes, number 8. This is ODE, but it's very easy. Last one. Let's first of all consider the last one, and we will return to the 7. So the last one here, I will show the method. This is with separable variables, yes. So, and since it is separable variables, we can write here dy over dx equals to this one, cubic root of 2y plus 1 tangent square x. And now we can write here dy divided by cubic root of 2y plus 1, which will be equals to tangent square x times dx. So we will just integrate both sides of our equation and find here the solution. And find here solution. So you can see the left side only depends on y, right side only depends on x. Okay, I think it's very not so difficult. It's clear for you. Let's continue with the 7 one now. Now it will be last one for us, number 7. So any idea here, students? So I have showed for you number 8. So we have only number 7 now. Think about this number 7 now. Sorry. So here it will be better if you replace it to if you replace logarithm x, for example, but here x tends to from 4, it's from 4 to plus infinity. So any other idea here? Or here we can just expand the function here, 3x and logarithm x also. And top here we have x squared plus 1. Top here we have x squared plus 1. But here, logarithm x, we can change with x, for example. And it will be x squared plus 1 dx divided by 3x plus x minus 1. So, and we need to compare the next function here, x squared plus 1 divided by 3 times x plus log. So we change it, for example, by x minus 1. So here we can do it less than or equals to less than or equals to. And also we have a to the power of x. What kind of replacement we can do here for a to the power of x here? I think here the answer is converts to the positive value, any? It will be correct answer. Because of here, you can see the denominator tends to infinity faster than the numerator. Because of here, a to the power of x and a is greater than 1. That's why we can conclude that it is tends to, it's converts to the any positive value here. Because of here, from 4 to plus infinity. Okay, we will do it also at home. I will send to the group the solution, okay? So any questions now? So we have number 7, which we need to solve at home, and here. And here we have, so which one it was? We have number 3, yes. So here I have 2 answers, 2 questions, number 3 and number 7, which we need to do at home, okay? You can take a photo, number 7 also. Have you done it? And the number 3, one more time. Okay, any other questions? So as I said, we will continue tomorrow, but a Zoom again. So, and we'll try to put one offline advising hours before your exam. Your exam mathematical analysis will be 21st of January. So we have the time. Link of the group. Just a moment. It was a group, discussion group. It was. You can just search. It's like ttpu. Let me write here. ttpu mass one discussion. Discussion 20. Like this. So this is the group where we can discuss other questions also. And here also you can find some practice notations and some samples also here we have. Okay, other questions? No questions? If no questions, we'll close today's session of advising hours, and tomorrow we'll continue. Bye. Thank you.